In this video, we're going to do some extra examples involving log functions. So the first one here is 7x squared times ln of x squared over 14. So for this one, we're going to want to use the product rule because I have a function of x's multiplied by a function of x's. Now, you might think when I compute the derivative of this inside bit that I need the quotient rule, but ln of x squared over 14 is the same as 1 over 14 ln of 1 over 14 x squared. Okay, so it's just a constant times x squared. It's just a polynomial. So we have our first function and our second function. Okay, so when we compute the derivative, so y prime is going to be the derivative of that first function times the second function as it was, plus the derivative of the second function times the first function as it was. Okay, so the derivative of 7x squared is 14x. Okay, now the derivative of ln of 1 over 14x squared. So when you take the derivative of a log function, it's 1 over the thing, okay, times the derivative of the thing. So when we bring the 2 down, it's going to be times 1 over 7x times 7x squared. Okay, so we're going to get some canceling going on here. So first of all, the 7 and the 7 go away, and also the x squared and the x squared are going to go away. Okay, so this is 14x times ln x squared over 14 plus, now this is 1 over 14, 1 over 1 over 14 is the same as 14. Okay, and then there's the only thing left over is just an x. Oops, I forgot my bracket. So, looks like that. Now if we want, we could factor out 14x, and we would get ln of x squared over 14 plus 1. Okay, so that would be our derivative here. Okay, let's try another one. So this one we're going to use the quotient rule. Okay, so I have a log function over t plus 1. So y prime is going to be the derivative with respect to t, ln of t squared minus 1 times t plus 1 minus the derivative with respect to t of t plus 1 times the top all over the bottom squared. Okay, now the derivative of ln of t squared minus 1 is the, so we need the ln, so it's going to be over the inside. Okay, and on the top you could put the derivative of the inside. So 2t over t squared minus 1 times t plus 1 minus derivative of t plus 1 is just 1. And this is all over t plus 1 all squared. Okay, now we could simplify this a little bit because t squared minus 1 is t plus 1 times t minus 1. Okay, so I get a little bit of cancellation there. The t plus 1s go away. Okay, maybe to make this look a bit nicer, I might want to multiply the top and the bottom by t minus 1. Okay, so I'm multiplying the whole top here, so it has to go to this term and also to that term. That's just going to get rid of the fraction within the fraction, because this t minus 1 here is going to cancel with that one in the first term. So we're going to have 2t minus t minus 1 ln of t squared minus 1 all over t minus 1 times t plus 1 all squared. So that's our derivative without any fractions within fractions. Okay, let's try another one where we don't have ln, we have log. Okay, so again, I need the product rule. So here's my first function, and here's my second function. So y prime is going to be the derivative of the first function times the second function. Oops. Plus the derivative of the second function times the first function. Okay, so the derivative of 2 to the 3x is 2 to the 3x times ln 2, and we're multiplied, so we have this sort of inner bit of 3x. So we want to multiply by the derivative of the inner bit, which is 3. Okay, now all of that is log times log 2 of 4x minus 1. Okay, when I do a log derivative, it's 1 over the inside, okay, times ln 2 because it's log base 2. But then I have to use the chain rule, so the derivative of the inside is 4. So I'd multiply by 4. I could just put the 4 up here if I want. And then times 2 to the 3x. Okay, so this is my derivative of the inside bit. Then maybe we want to factor out, the only thing I think they have in common is this 2 to the 3x. Okay, so I'm going to have 3 ln 2 times log base 2 of 4x minus 1 plus 4 over 4x minus 1 times ln 2. Okay, so that would be my derivative here. Let's try another one. So when it says log with no base, okay, we actually mean log base 10. Okay, so this is log base 10 of this thing. So if we wanted to compute the derivative, it's going to be 1 over the inside times the derivative of the inside. Now the derivative of the inside needs the quotient rule, and the derivative of the top needs the product rule, and one of the things here needs the chain rule. Okay, this is a complicated derivative. We could do it that way, okay, but it's not a lot of fun. So why don't we simplify first? So we're going to simplify using the log rules. Okay, so when I have log of a fraction, I can take the log of the top minus log of the bottom. Okay, I already just got rid of the need for the quotient rule. Okay, now I'm going to take this even further. So I have 2 times x squared times 4x plus 3 all squared. So I can break these all up doing addition. So it's log 2 plus log of x squared plus log of 4x plus 3 squared. So now I've taken out the need for the product rule. And now I can also, to make my life a little bit easier, I can also bring down these exponents now. Oops. Okay, so this is going to be 2 log of x plus 2 log of 4x plus 3. And I don't know where I got the 2 from, because that should have been a 5 the whole way along. Okay, minus, now I cannot bring this x squared down because it's attached to the minus 1. And when I have minus inside of a log, I can't break it up. Okay, so I'm stuck with this one as it is. Okay, so now that we've simplified, now we can take the derivative of each part. So it's going to be the derivative of log 2 plus 2 times the derivative of log x plus 5 times the derivative of log 4x plus 3 minus the derivative of log of x squared minus 1. Okay? Now, log 2, this is a constant, okay? It's just a number, right? It's so you could compute that on your calculator, in fact. Okay, so that derivative is going to be 0. Okay, now the derivative for log x is 1 over x times ln 10, because we're in base 10. Okay, now when I have, so that's because it's just x, the derivative of the inside is 1. So over here, the derivative of the inside is 4, so I'm going to have 4 over 4x plus 3, so the inside bit, times ln of 10. And then I'm going to have here the derivative of the inside is 2x over x squared minus 1 times ln 10. Okay, now we could simplify this a bit. So it's going to be 2 over x ln 10 plus 20 over 4x plus 3 ln 10 minus 2x over x squared minus 1 ln 10. Okay, I would just leave it like that. I guess you could factor out a 2 over ln 10, but this is fine. Okay, one more. This is a complicated one because we're going to have multiple chain rules going on. And again, I need the product rule. Okay, so here's my two functions. So maybe we want to compute their derivatives separately. Okay, let's call this one u and this one v. Okay, so when we do u prime, I have a multiple chain rule. Okay, so first I have this ln, maybe I should have made that better. First, my first inside bit, is this ln of 2x minus 1 is in power 5. So the outermost derivative is 5, that inner bit, to the power 4, but then I need to multiply by the derivative of the inner bit. Okay, and technically this is also another chain rule because I have 2x minus 1 inside the ln. So that's going to be 5 ln of 2x minus 1 to the 4 times 2 over 2x minus 1. So it's 1 over the thing times the derivative of the thing. So it's the derivative of the thing over the thing. Okay, so that's the derivative of u. Now let's do v prime. So here, this one is actually cos of x squared minus 3 all to the power 7. Okay, so again, this is my inner function to begin with. So I'm going to have 7 times the inner function to the power 6. And then I'm going to have to times by the derivative of the inner portion. Okay, now I have another inner portion, so I'm using the chain rule again when I take this derivative. So it's 7 cos to the power 6. Okay, so the derivative of cosine is negative sine of the inside, but then I have to multiply by the derivative of the inside. So I get cosine, 7 cosine to the power 6 of x squared minus 3 times negative sine of x squared minus 3 times 2x, the derivative of x squared minus 3. So if I simplify this, if I bring the negative and the 2x up front, I have negative 14x cos to the 6 of x squared minus 3 times sine to the power 1, x squared minus 3. Okay, so those are my two derivatives. Now we can actually do f prime of x. So it's going to be u prime times v plus v prime times u. So u prime is so it's 5 times ln of 2x minus 1 to the power 4 times 2 over 2x minus 1 times v as it was, so that's cos 7 x squared minus 3 plus the derivative of the v prime, so this is negative 14x cos 6 x squared minus 3 times sine x squared minus 3, okay, times the first function as it was, so ln 2x minus 1 all to the power 5. Okay, so we're going to have some like terms in here that we can factor out. Okay, so ln of 2x minus 1 appears to multiple powers. Okay, as does cosine of x squared minus 3. So I can factor those out to the front to the smaller power. Okay, so I'm going to have ln 2x minus 1 all to the power 4 times cosine to the power 6 x squared minus 3. So then what's left over from the first term is going to be 10 and one more cosine. So the 5 times the 2 is 10. Okay, plus this times this cosine. There's only one of them because I took out 6. And it's still over 2x minus 1. And then over here we have a minus. All these cosines are gone. So we have 14. I guess I don't need to be up high. There's no fraction. So I have 14x. All those cosines are gone. I still have the sine of x squared minus 3. And then I have one more ln of 2x minus 1. Because there was 5 and I took out 4. Okay, so this is how I would leave my derivative.